In this lesson, we're going to be talking about absolute value equations. And basically what they are equations that have absolute value bars in them. So I'm going to show you the method on how to solve these. But the first thing we need to do is remember what does absolute value actually mean? The absolute value of a number is a number's distance away from zero. And one thing we know about a distance is that all distances are positive numbers. So anytime you have the absolute value of a number, it's always going to be positive. So let's think about this first piece here that you see. It says the absolute value of x is equal to 7. Think about the different possible values you could have for the x. Couldn't I have x is equal to positive 7 and x is equal to negative 7? Leaving us with two answers here, one here and one here. Well, what you're going to learn here with absolute value is that oftentimes there are going to be two different solutions. So let's go ahead and take that concept and solve an actual equation with absolute value bars. Okay, so let's go ahead and take a look at this first example. It says the absolute value of x plus 7 is equal to 20. This is a very basic example. And what I mean by basic is that there are no operations that are outside of the absolute value bars. All we have is one step inside. So at this point right here, what we want to do is break this problem into two cases. And I usually like to write out the word case just like this. So case 1, that's going to be here, and case 2, that's going to be over here. Case 1 is going to be exactly what you see. It's going to be x plus 7 is equal to 20. Now, the only thing that changed here was the absolute value bars. What I did was I took them away. Okay? Now, all I want to do is solve this out. So if I solve this equation, I'm going to subtract 7. And that's going to leave me with x is equal to 13. This is one of my solutions to my problem. But I also have case 2 to worry about. Case 2 is where something changes. Let me show you what changes. I'm going to write down x plus 7, but the thing that's going to change is the 20. Right now it's a positive 20, and I'm going to intentionally make it a negative 20. By doing that, I'm going to account for both the positive and the negative of the variable. So let's go ahead and solve it. That's going to leave me with x is equal to negative 27. So you can see that I have two answers here, just like I did in that top example. Let's go in and just kind of double check to make sure this worked. If I took x equals 13 and I substituted it in for the x value here, 13 plus 7 equals 20, and the absolute value of 20 equals 20. So this solution works. Now let's go ahead and check the other one. Negative 27, if I were to substitute that in the x, plus 7 is going to be negative 20, and the absolute value of negative 20 is equal to 20. So both solutions are possible solutions for this problem. This is where we might want to start looking back to the idea of set notation. And you might want to even write these answers in set notation if you'd like. Just as a reminder, it's going to be x such that x is equal to, I like to write my most negative number first. That's just a personal choice. And then x equals 13, which is the greater number. Alrighty, so that brings us to the end of the problem here. Now let's go ahead and take a look at another. The second problem is slightly different, and it's slightly different because of the positive 3 attached to that absolute value. Anytime you have a situation that looks like this, you always want to take care of the pieces outside of the absolute value before working on the cases. So let's go ahead and subtract 3 to begin this problem. All right, that's going to leave me with the absolute value of x minus 4 is equal to 5. All right, now I'm at a place where I don't have anything outside of the absolute value bars. So now I can go ahead and break it into my case 1 and my case 2. So I'm going to go ahead and write that down, case 1 and case 2. And I'm going to go ahead and work those problems. Case 1 is going to be x minus 4 is equal to 5. All I did was take away the absolute value bars. And I'm going to go ahead and add 4 to both sides, giving me x is equal to 9. So 9 is one of my solutions. Case 2 is going to be x minus 4 is equal to negative 5. That's the only thing that's going to change. And I'm going to go ahead and add 4 to both sides. That leaves me with x is equal to negative 1. So those two numbers are the numbers that I can place into my absolute value bars where that x is, as basically they're my replacement values, to get the correct solutions. I could also write this again in set notation if I'd like. X such that x is equal to negative 1 and x is equal to 9. I can do that if I prefer. Okay, let's go ahead and bump it up just a little bit. All right, here are my 2 examples. Now you'll notice that I have quite a bit of work on the outside of the absolute value bar. So I do need to take care of that before I start breaking it into 2 cases. So the first thing I want to do is look at that negative 8 and negative 4. And the question is, well, which one do I eliminate first? Well, if you look here, I have multiplication and then I have subtraction. So I need to get rid of that subtraction first, just like I would in a regular 2-step equation. So I'm going to start by eliminating this 4. I'm going to go ahead and add 4 to both sides. So let's go ahead and do that. I'm going to be left with negative 8 with my absolute value of n over 3. My 4's are going to eliminate, and that's going to leave me with negative 8. All right. The next thing I want to do, since these are being multiplied by one another, I'm technically going to be going and dividing both sides by negative 8. In doing so, those negative 8's are going to eliminate, leaving me with the absolute value of n over 3 is equal to 1. Okay, now that I've eliminated everything on the outside, I can go ahead and begin breaking into my case 1 and my case 2. Case 1 is going to be n over 3 is equal to 1. And I'm going to go ahead and solve that out. I'm going to multiply both sides by 3. That will eliminate my 3's to give me n is equal to 3. That's one of my solutions. The other solution is going to be n over 3 is equal to negative 1. I'm going to go ahead and multiply both sides by that 3, same as I did before. And I'm going to get n is equal to negative 3. Alrighty, so there are my 2 solutions. If I'd like to write those in set notation, I can. Now, notice that my variable has changed from x to n. So I'm going to say n such that n is equal to negative 3 and n is equal to positive 3. Okay, let's try one more, and then I'm going to show you some not special cases, but some special situations that occur. All right, so this time I have, you'll notice that the biggest difference with this one is not only do I have operations outside of the absolute value, but what's inside my absolute value, I actually have a 2-step situation versus a 1-step. So let's go ahead and take care of the outside first. I have negative 7, and then I have 3 being multiplied by my absolute value. So I do want to eliminate anything that I'm adding or subtracting first. So I'm going to go ahead and get rid of that 7, and I'm going to eliminate him first. So let's go ahead and rewrite everything. Again, notice how nice and neat and organized my work is. It's very important that you stay nice and organized. The next step is to eliminate the 3. So I'm going to divide both sides by 3 since it's originally being multiplied. And therefore my 3's will cancel out. And I'll be left with 2k plus 4 is equal to 2. Okay, at this point in time, you can see that everything outside of the absolute value bars have been eliminated. So at this point, I can go ahead and start breaking it into my case 1 and my case 2. Okay, all right, case 1 is going to be 2k plus 4 is equal to 2. And what you can see here is that the only thing I really did here was bump up the inside where it's now a 2-step equation. But luckily, we studied that a couple sections ago, so we should be okay with that. 2k is equal to negative 2. And I'm going to divide both sides by 2 to give me k is equal to negative 1. Working with my case 2, I have 2k plus 4 is equal to, I'm going to change my 2 to negative 2, and I'm going to go ahead and simply solve it out. So if I have 2k is equal to negative 6. Notice how I'm not skipping any steps. I'm showing all of my steps. I always want to do that as I'm working through these problems. And there I have my other answer. All right, so if I want to check myself, all I need to do is take those values and substitute them back into the original problem, and you should have two answers that work perfectly. So my set notation will be k such that k is equal to negative 3, and then k is equal to negative 1, and I'm done. Okay, so those were quite a few problems just practicing the skill, but I do want to show you a unique situation now. Okay, the question that I want to ask is, can you have a negative absolute value? Meaning, can you have something that looks like this above? The absolute value of x is equal to negative 5. And the answer is no, you can't. Now, you might be thinking, well, what if you add a negative outside? Well, yes, in that case, that would be okay. But that's not what we're doing here. So good thinking, but what we're looking at is just, can you have an absolute value that equals negative? And the answer is no. So let me show you two situations that this is going to occur and what that looks like. So here we have this next example, and what I notice here is this. Notice the number on the right-hand side. Do you notice how it's a negative number? Everything else up to this point has been a positive number. This might lead my thinking into the direction of, well, this might be a problem. But let's go ahead and continue just to see what happens. So let's go ahead and I'm going to start by subtracting 5, just like I would in any of these problems. By subtracting 5, I'll be left with 5 absolute value of 7x minus 1 is equal to negative 40. I'm going to continue on just like normal. It is interesting that that number is negative, but let's see what happens. Let's go ahead and divide both sides by 5. My 5s will eliminate, and I'm left with 7x minus 1 in the absolute value bars, and that's going to equal negative 8. Okay, at this point in time, I want you to look at what we have here. Doesn't it look similar to our example up above, where I have the absolute value of something? It doesn't even matter what number I put in there. No matter what, I'm never, ever, ever going to get that to equal a negative number. It's never going to work. So therefore, this is going to be a problem that has no solution. So at this point, there just isn't an answer. So that's all you need to put is no solution. Now, do you remember at the beginning of this problem, I mentioned that that negative 35 was negative, and that might indicate to us that this is going to be a unique situation? Well, it's not always like that. Look at this next example. Do you see how this next example, I start with that negative 5? Well, that might trigger in my mind that there might be a no solution situation here, but it doesn't guarantee it. We have to solve out the problem. So let's go ahead and solve out the problem. I'm going to start this problem by adding 8, just like I would normally. Do you see what that did? I'm going to go ahead and write x minus 3. But then negative 5 plus 8, it actually brings me into the positive numbers. So just because that number was negative does not mean that this is going to lead to a no solution problem. You have to actually do the problem. This is a perfectly workable problem now. At this point, I'm going to go ahead and break it into case 1, and I'm going to break it into case 2. Case 1 is going to look like this, and once I solve out the problem, x is going to equal 6, and then case 2 is just going to be changed to a negative 3. So I'm going to say plus 3, and then x is equal to 0. So those are my two solutions. So I can write this in set builder notation just like I did before. It works perfectly. So the key to this example, the reason I showed this to you was, just unlike the last problem where it had that negative number, it doesn't always guarantee that it's going to be a no solution. You have to go ahead and take care of the other operations first. And once you get to that point that all the operations outside of the absolute value are gone, that point you can determine whether it's going to be no solution. Okay, that's going to be the end of our lesson on absolute value equations.